Hello everybody. So today we will talk a little bit about our ComNets emulator. So our ComNets emulator, for a little bit of context, is like a middle point between a simulator and between a real implementation. A nice thing about simulations is that you can scale them as big as you want. You can simulate millions of nodes, you can simulate millions of devices that communicate with each other, and then they are created to have a rough estimate of how your new protocols or your new programs will behave. However, the problem with the simulations is that they are as accurate as the models are. If you are simulating something with the wrong models, your simulation will simply not be correct. Uh, on the other hand, the implementations are great in the sense that you're already using real life systems, so you do not have to worry about inaccurate models. So if you are deploying this on real devices, on real systems, then the behavior will be close to reality. However, the problem with the real implementations is that they do not scale. So you cannot, unless you have the infrastructure, you cannot simulate and deploy millions of nodes, millions of cell phones, millions of devices, etc. Another problem that simulations and implementations have is that if you want to simulate something, what you would usually do is that take, you would write a protocol for a simulation platform, such as NS3 or so on. So you would have to write your protocol for that simulation platform, simulate their behavior, and then write and implement the actual protocol for the devices where you want to run it. So you can implement, develop and deploy this, for example, in routers, in Raspberry Pis, and so on. So you spend time de developing the models and the protocol in the infrastructure of the simulator, and then you spend time in the deployment and development of the actual protocol on actual real devices. The problem is that these two things are redundant and you cannot fully use the implementation in the simulator and at the same time as the implementations of real-time scenario. You usually have to develop two things. So because of that, we wanted to develop our emulator, which works somehow as a middle point between a simulation and a real implementation. The idea behind our emulator is that we want to develop and write our protocols, our programs, our applications in the same way as we would write this if we wanted to implement it on real devices. And then we want to use tools such as Mininet or TC from Linux in order to emulate and simulate the links, the connections between these devices. This allows us somehow to have a little bit of the scalability of the simulations because the links and the number of devices are emulated so we can scale them. And at the same time, we will not waste time to implement our protocols and our system twice. Because if we implement them for our emulator, they can run in real systems at the same time. So how does this work? This works using Docker. Docker allows you to develop your application and your protocol in a container that you can run inside our ComNets emulator, but you can also run in a real system. So basically, a server running Docker can run your application, and our emulator can run your application too. Why is this useful? This is useful because you do not have to develop two things for the emulation and for your real implementation. You can develop your software, test it and emulate in our emulator, and if it works, if you like the behavior, you can deploy it right away in a real system. Basically, Docker manages the NFV functionality of our emulator, and Mininet manages the SDN part of the system, and it also manages the link emulation, the link characteristics in terms of throughput, delays, packet erasures, packet errors, and so on. So within that context, now we can go to use our ComNetsEmu. In the link in the description, you will find the access to our repository. It's publicly available, so you can go there, clone the repository, and install the ComNets emulator. It's very simple. The first step is to clone the repository using Git, and the next step is to install it in a Vagrant virtual machine. This is the recommended way to install our emulator. In this way, you do not have to mess up with the system settings, with the system configuration, and our emulator will run as a virtual machine. So anything you do in the emulator will be completely isolated from your system. This is the best way to do it. I already cloned the repository. I will show it here. So after it's cloned, it appears as ComNetsEmu folder. I can go to that folder, and after you clone it, the first step is to do vagrant up ComNetsEmu. This will build the virtual machine. The first time you run this command, it's gonna take around 20 minutes because this vagrant file is some form of recipe in order to build a virtual machine. And once this virtual machine is built, like I did before, the next step, or the next time you run this vagrant up, it will be very fast. So now vagrant up is ready. This means that I have now my virtual machine running in my system. If I do vagrant ssh ComNetsEmu, I am inside the virtual machine where the ComNetsEmu is running. Right after this is done, the next step that you want to do is to do some post installation commands. The first post installation is to go to test containers. So you go to ComNetsEmu / test containers, and you will have to run the build.sh command. So bash build.sh. So do not be scared of running these commands because all of this is running inside your virtual machine, not on your actual system. The next step is to go to ComNetsEmu util, and there you would have to run bash.install.sh-u. This will upgrade the virtual machine to the latest software. You press Y, and once it's done, you are basically ready to use our emulator. The next step, also written in the README in the repository, is to run the example. So run sudo make test. Oh, sorry, I have to be in the root folder of the ComNetsEmu. And now if I run this again, this will run the test, and hopefully it will tell that all the tests passed. If this is the behavior that you are observing, then it means that your installation of the emulator was successful, and then we can start developing our own application. I will come back once the tests are done. So all our tests passed successfully. Let us build our first implementation. The system that we will build now looks like this. I will explain what of it all is. We will build a system that has two host computers, host 1 and host 2, which are emulated hosts. They will be connected to each other through this network topology. Each one will be connected to a switch 1 and switch 2. And these connections, each link will have 10 megabits per second throughput and 10 millisecond delays. The IP addresses of each of these hosts will be 10.0.0.1 and 10.0.0.2. The host 1 will act as the client, and the host 2 will act as the server. This topology can be built as complex as you want. You can have as many hosts as you want, and you can have as many applications running as you want. In this very simple example, in this very simple template, we will have simply 2 switches, 2 hosts, and 1 application. In this case, our application would be an echo server. We are basically running an echo server as a network function, as a network virtual function, in the sense that this is gonna be a Docker container running a simple echo server, which will echo back to the sender each incoming TCP packets. So very simple. If we have a more complex topology, we can make use of SDN to manage the traffic and to spawn different echo servers or different applications and to do anything we want. But now, to keep it very simple for introduction, this is what we're going to build. The host one will, on the other hand, have a simple application running that the only thing that runs is bash. Here we will send a TCP packet to the host 2, and the host 2 will echo it back to us. In order to build this system, in our emulator, we will need to create something called net, an object called net, and an object called manager. This will all become clear when we go into the code, but so far, this is the topology that we are interested in, right? So let's do that. Something nice is that our virtual machine, our Vagrant virtual machine running the ComNets emulator, has a shared folder with our system where the actual repository lives. This means that any change that I make in my physical system and my host system to that folder will be reflected inside the virtual machine. So this is nice because I can use any text editor that I have installed in my host system in order to develop my applications. So I will open a new console. This one is inside my system. The console on the left is the ComNetsEmu, the ComNetsEmu virtual machine. The console on the right is my system, my host system. Inside the ComNetsEmu, we have different things. We have examples. So let's go to the examples folder. And what we will develop now, you can find it inside this folder called Echo Server. However, we will develop it from scratch for you to see how simple it is. So I will make a new folder and let's call it YouTube Echo. So this will be the example that we will develop now. Let's go to that create folder and let's open my text editor here. Now I can close this console. Okay, so now I'm inside the folder that I created. We need a few files in order to make our application run. So what will be these files? The first file will be our application, our actual application, right? And this application, we will containerize it. The application that we will develop is very simple. It's an echo server. However, this application can be as complex as you want. You can make this application super complex. This application can connect to many nodes, can listen requests and act on them. It can be machine learning applications. It can be control applications. It can be any type of applications that you want that has to be connected to multiple nodes. For a simple template, we will use just an echo server. So let's create this application. Let's call it server.py. So this will be a server written in Python. Something else that we have to do is to containerize our application. To make this a container, we need a recipe that will create a Docker container out of our application. So this will require a Docker file. To create very easily and to provide a very easy way of creating this Docker container, we will have an instruction bash script that will tell the instructions on how to create the Docker file, how to create the Docker image from this Docker file. So let's call this build image or build Docker image.sh. Another file that we will need to use is something called topology.py. This is basically the file that will instruct our ComNet emulator in how exactly we want to build the topology of our network. So in this topology.py, we will have the code, the Python code, to create this network topology. Very simple so far. So the first thing we want to do is to create a Python echo server. This is very simple. Import socket. Then we need to bind the socket. Socket.socket. We want an internet socket. And we want our socket to be a sock stream. Here we create the socket. The next step is to bind the socket to a particular port. So we define a server address. This means that this address means any IP address at the port 65,000. We will bind the socket to this address. So we create a socket and we bind it to the address. The next step is to ask the socket that we created to listen. Now the socket will be listening for connections, for TCP connections, and then we want to echo back everything that we receive. So we create a loop while true. We want maybe to print waiting for connections. And once we receive a connection, we will accept it. So sock.accept. This accept returns a connection and it returns a client address. So we are in a loop, and in this loop we will accept any connection, and we will then try to echo back whatever we receive. We can print some more information. Let's print connection from, and then we print the address of the client. And while we are receiving data, data equals connection dot receive. We set a buffer. Let's say 16, a small buffer. And if we receive data, then we print received. Let's print in this way. Let's print back the data. And connection dot send all data. If we receive no data, let's print no data from client address, and we break the loop. Finally, connection dot close. And here we have a very simple Python echo server. I chose Python, but this server can be implemented in any in any language that you want. This can be Go, this can be C++. Your application can be done in any type of language that you want. So once this is ready, we need to containerize it. So let's edit our Docker file. Our Docker file will be very simple. We need to specify an image that will be our base image. In this case, let's say Python 3.6 Alpine 3.9. This will be the base image. All we need is something that is capable of running Python. And in this image, we will copy our server.py. We will copy it into home server.py. And if we run this image without any command, we want it to default to running the server that we created. Home server.py. This is very simple. So this is the Docker file that we need. Let's choose a base image, copy our application, and run that application. Simple. The next step is to build, it's to write a bash script to build the image. So here we basically want to run docker build. This is the command. We have to give it a name to this Docker image. Let's call it echo server. The file that we will use, we have to specify. It's Docker file, and it's in this folder. That's pretty much all. So this is inside my background virtual machine. Let's clear it. So if I change to inside my virtual machine to ComNetsEmu and I go to examples, I see that all the changes that I made are reflected here. So if I go to YouTube Echo, all my files are here. So we can run the Docker image, the bash script that we just created. This created the Docker image and copy the server. So this basically tells us that our Docker image is up, and we can now create Docker containers based on that image. So the next step is actually to build the actual topology. To keep the video short, instead of manually editing this topology file, let's copy the one we have in the repository. So we go to the repository, we go to echo server, we go to topology.py, and we copy it here. And here we have it. Let's go over this file very simple, very fast, and it's not so complicated. We need a number of imports that are related to Mininet and to our ComNet simulator. This you can copy and paste as a template, and this will be the main function. Something that if you want to do some auto testing, you need this. Otherwise, we can delete it. So all you need is to set the lock level. This is if you want to have some printed information. Then you create a net object, which use the container net to create it. It used as a controller, something called controller, as a link, something called TC link, and it will not open X terminals. What is a controller and what is a TC link? This you can find in other examples. This basically allows you to have a simple controller, or you can have an SDN controller for your switches. And TC link is a type of link that uses TC tool from Linux, which allows you to set delays and throughputs and so on. Net, this object, is the argument for manager. As I told you before, you need a net object and you need a manager object. This is what we are creating here. We create the net, and manager will use net as an argument. And the type of manager that we want is a VNF manager, a virtual network function manager. The next thing that you want to add is a controller. Net.addController. This will create our controller. And here it is expressed as this gray box, and that will be done with this command, net.addController, and we can give it a name, Z0. So now we have all the abstract objects that we need to actually create our system. In this case, we will create host 1, and in order to create a host, we do net.addDockerHost. So we use net and we create a Docker host. We have to specify the name, h1. We want to specify the Docker image that we want to use for this host. In this case, we can use the dev test, which is an image that we provide in our ComNetsEmu. This is basically the image where we can host our different applications, where we can host different Docker containers. So this is basically an image in which we can run Docker containers. We need to give it an IP, 10.0.0.1. We have to give some Docker arguments like the host name. We do the same with host 2. We create exactly the same. So now we created H1 and H2. Now we have to create the switches and the connections. We create two switches, switch 1 and switch 2. To do that, we say net.addSwitch and we give it a name, S1 and S2. Now, once the switches are connected, we can link the switches and the host. We do that with this instruction, net.addLink. This instruction takes as the argument the two entities that we want to link, the bandwidth in megabits per second, and the delay. In this case, the bandwidth will be 10 megabits per second and the delay will be 10 milliseconds. We connect the switch 1 with host 1, we connect switch 1 with switch 2, and we connect switch 2 with host 2. Basically, we build this topology. Host 1 connected to switch 1 connected to switch 2 connected to host 2. And each link has 10 megabits per second throughput and 10 milliseconds delay. Once this is done, all we have to do is to start the net object, net.start. So now what do we have? We have a system that is emulating two physical machines in which we can run virtual network functions using containerization, using Docker. So we will run our images here. So for the server, let's say, or service 1, we want to add a container. And actually, there is a small error here because what I want to do is to add the server in H2 and the client in H1. Here is written the other way around, so we can simply change the name. We can say that server 1, let's call this service 2. We have to add a container. We will call this service 2. we will add this in H2 in the second host. This is the name of the Docker image we will use. This image is Docker server, which is the image that we built here. If you do cat and you do build Docker image in this bash script, we created our Docker image with the name echo server. So that is the Docker image we're using. And this is the command we want this image to run with. So basically we want to start this image, and when this image runs, we want to run this command inside that image, which basically means run our created server. Now, this, as we are changing the name, the service one, we will create a container in called SRV1. We want to create it in H1, and we want to run as an image dev test. This image has bash, it has the ability to ping, so this image has simple commands, so we can build this image. And the command that we want to run here is bash. Right? We removed all the auto test part above, so it means that this is no longer needed. So we can delete that if statement. And then we can spawn an X terminal in service one. So this means that we will, for the service one, for this Docker container, we will create a terminal. And then we have CLI net. This allows us to control to have access to the net in a console interface. Once this exits, once we are done with this, all we have to do is to remove the containers, to stop the network, and to stop the manager. And this is basically the topology that we are building. Okay, so now let's see if everything works. So we already did this, but if you are doing it from the first time, we can run the bash script to create the Docker image. Bash build docker image.sh. This creates Docker image. And after that, we have to run our topology. So mininet has to run as sudo. So sudo python3 topology.py. This will run this command, and this will give us a terminal to access service one. We do it, and we can see that everything runs, and this is our terminal. If I do APA, I can see that I am actually the service 1, 10.0.0.1. This is my IP. I can ping the other host, 0.0.2. And if you see, the ping time is around 60 milliseconds. This makes sense because if you see the topology, each link has 10 milliseconds delay. So a ping has 10 milliseconds, 10 milliseconds, 10 milliseconds, and then the answer back. So this basically has 30 milliseconds in one way and 30 milliseconds in the other way. These other milliseconds that sometimes come here and there depend on the CPU usage. So the virtual machine that we are using have some CPU limitations. So sometimes because of that, we will have this little bit of jitter. If you want to reduce this, you can assign more CPU time to your virtual machine. This is also explained in the README in the repository. Okay, so we can clear this. So now we can communicate with our echo server. So let's send hello server. So if I want to send this to the server, I can use Linux pipes, and I can use a Linux command called nc. This allows me to send UDP packets or TCP packets to any server, to any host in my network. So I will specify the IP address of the server, and I want to specify the port. So I program my port to be connected to the 65,000. If I do this, I receive a hello server as an answer. This means that the server is responding. So this means that this is working. If you do not trust this, you can send this same command to any other node, let's say 10, which does not exist. And what happens is that NC will try to establish a TCP connection. It will not be able to do it. And then after some timeout, it will return without any answer. If you compare this with the correct IP, we get an answer. So this is how we implement a very simple application. So from here, you can use this as a template. You can use these files as template files, and you can build your application as complex as you want. Remember, if it runs in Docker, it can run in our emulator, and then you can run this application everywhere. So thank you very much. This was our introductory video. Bye-bye.